While officials claim that both blasts were hydrogen explosions, Professor Christopher Busby, a nuclear energy expert, opines that the blast at Fukushima Daiichi Unit 3 may have been a nuclear fission criticality. Indeed, it's plain to see that the explosion at Unit 3 differs significantly from the explosion at Unit 1, not just in terms of magnitude, but a whole spectrum of features. In this video, we'll examine some of those features. Unit 3 building initially implodes, and from its first seconds, its blast differs from Unit 1's. Its first smoke is pitch black, and while the force of Unit 1's blast is almost entirely lateral, the forces from Unit 3 are almost entirely straight upward, carrying massive debris 5 times the height of the building. Indicative of extreme temperatures, an apparent ring vortex forms immediately and constrains lateral smoke projection. Fire appears to be sucked up and into the vortex. Ring vortices like this are classic features of nuclear explosions. Indeed, a classical mushroom cloud cap eventually blooms from the blast, invariably driven by the same thermal forces. For context, let's compare the Fukushima fission reactor blast with a known test of a nuclear fission weapon. The classic thermally driven downward rotation of mushroom cloud caps is equally apparent in both cases. While all nuclear explosions have these thermally driven characteristics, not all explosions with these characteristics are nuclear. So while the visual evidence may be consistent with Busby's speculation, it is not perfect proof that Unit 3's blast was in fact a fission criticality explosion. Such proof could come from isotope ratio data that TEPCO has yet to release. But one has to wonder, what are the odds that such a massive explosion with distinct nuclear fission characteristics arises from a nuclear fission power plant and isn't a nuclear fission event?